Greetings all, I'm Jesse Kristen Preston, and this is my big data presentation for INFS 762. The topic I'm presenting on, as you probably already guessed, is Apache HBase. We've had a bit of an introduction to HBase already through the course lectures, but in case you're still wondering what it is, the short answer to that question is that HBase is a database designed for big data. To go into a little bit more detail, Apache HBase provides random, real-time read-write access to data in very large tables. And by large tables, I mean ones with billions of rows and millions of columns. HBase is especially useful for storing and sorting through massive quantities of records with large amounts of missing or unimportant data. This could mean a task such as finding the top 10 largest values when only 0.1% of 2 billion records have data for that attribute. Since its creation, HBase has become popular with several data-driven websites, such as Facebook's messaging platform, and we'll look at this example in a little more detail in a bit. But first, let's explore more about HBase. HBase began as a project by the company PowerSet out of a need to process massive amounts of data for the purposes of natural language searches. It was modeled after Google's Bigtable, which runs most of Google's applications. The key design difference is that HBase runs on Hadoop. So, just as Bigtable leverages the distributed data storage provided by Google File System, HBase provides Bigtable-like capabilities on top of Hadoop distributed file system. HBase is now a top-level Apache project that is being used by Pinterest, Amazon Web Services, Bloomberg, Salesforce, Rocket Fuel, Yahoo, and many other companies. Some of the features that have led to HBase's popularity include scale-out architecture that allows an application running on HBase to have its capacity increased by adding servers, consistency between servers to guard against node failures or blocking writes to the same record, high availability with multiple master nodes for ensuring continuous access to data, automatic sharding processes to transparently and efficiently scale out your data across machines in the cluster, active replication that streams data across locations for disaster recovery and data protection, security down to the table and column family level access, SQL access for both ad hoc querying and batch processing, full text search functionality designed for non-technical users and integration with external applications. Although I didn't see these benefits often listed as key features of HBase, I thought they were worth mentioning. So, Apache HBase provides fault-tolerant storage for large quantities of sparse data using column-based compression, making it capable of storing and processing billions of rows efficiently. Support across multiple Hadoop jobs allows an HBase data store to be used by one or more Hadoop jobs on a single cluster or across multiple Hadoop clusters. Apache HBase can run atop clusters of commodity hardware and integrates with some cloud computing providers, such as Amazon Web Services. If you've taken DSU's class on Information Technology Strategy and Policy, you probably noticed that these last two benefits coincide with concepts that promote a technology's progression towards computing as a utility, making them particularly appealing to executives looking to better align IT work with corporate strategy. Although this may not get as much attention as some of the technical bells and whistles, it would probably make a nice point in a project proposal that you're making to your bosses. HBase is good for many things, but it is not a wholesale replacement for all relational databases. When considering HBase, it's important to keep this in mind, along with some of its other shortcomings, such as the fact that HBase allows some SQL querying, but does not fully support SQL. For example, it does not have a query optimizer. It does not support cross-record transactions or joins. So complex querying of HBase must be done using some other application. Also, HBase is susceptible to cascading failures. If one node starts swapping, it can lose contact with the master node, causing another server to pick up that load and possibly becoming overburdened. If that second server fails, the failure can cascade to other nodes. Proper configuration, such as not running mixed workload types on a single HBase cluster, can help avoid these kinds of failures. As is the case with many distributed systems, you need to monitor the memory, the CPU, input and output, the network latency, and bandwidth of each of your HBase nodes to make sure they are operating within healthy parameters. Now that we've seen a little on what Apache HBase is, along with some of its pros and cons, here are some things you should consider if you're evaluating the appropriateness of using HBase for your next project. The first thing to consider is if your project involves big data. Since HBase was designed for big data, if your project clearly doesn't involve big data, then Apache HBase is probably not for you. If you're building some kind of transactional system, you can likely rule out HBase in favor of a relational database. If you do have big data, instead of a relational database, you find you need a variable schema where each row is slightly different than the others, then you should look at HBase. Finally, if you find that your data is stored in collections, for example, a collection for metadata, collection for message data or binary data, and that all of this data collections are keyed on the same value, then you need a key-based access to the data when storing and retrieving information. In this case, you should also consider HBase. Now, let's look at a few case studies of well-known companies that have decided to use HBase. One of the early big-name adopters of HBase was Facebook. When creating its messaging service, Facebook needed to store billions of records daily. Facebook considered using MySQL since it already had an extensive MySQL infrastructure, but they found performance suffered as datasets and indexes grew large. Another option considered was Cassandra, since Facebook purpose-built Cassandra for inbox-type applications, but they found Cassandra's consistency model wasn't a good match for their new real-time messages product. HBase was under consideration because it is a scale-out table stored supporting very high rates of low-level updates over massive amounts of data, exactly what is needed for a messaging system. HBase is also a column-based key-value store model, so it's good at fetching rows by key or scanning ranges of rows and filtering. Also something that's needed for a messaging system. A drawback was that complex queries are not supported. However, queries could be given over to an analytical tool like Hive, which Facebook created to make sense of the multi-petabyte data warehouse, and Hive is based on Hadoop file system, which is also used by HBase. Excuse me. Facebook finally settled on HBase after they considered the message application's usage and figured out what was really needed, which was a system that could handle two types of data patterns in instant messaging. The first, a short temporal data that tends to be volatile. The second, an ever-growing set of data that is rarely accessed. These two patterns are so different that it could be expected that two separate systems would be needed. But HBase works well enough for both and was chosen by Facebook. The other example is Twitter, which runs HBase across its entire Hadoop cluster. HBase provides a distributed read-write backup of all MySQL tables in Twitter's production backend, allowing its engineers to run MapReduce jobs over the data while maintaining the ability to periodically update rows. Twitter also has a number of applications, including its people search, that rely on HBase internally for data generation. Additionally, the operations team uses HBase as a time series database for cluster-wide monitoring of performance data. If you're interested in learning more about Apache HBase, here are a few links. Wikipedia is, of course, a good place to start for a quick primer, but Apache's HBase site has more specifics. The last link has several short examples of usages companies have found for HBase. And this concludes my presentation. Thank you.